Okay, so volume is max and recording has been started. So, hello everyone. Again, I am back with another video, and today I am going to discuss the Atcoder educational DP contest. So, without wasting much time, let's get started with the problem one. And this problem is frog one. Let's proceed to the problem statement. So, in this problem, we are having n stones, and each stone is numbered from 1 to n. Okay, so we are having one base indexing over here, and we are having height of each stone, which is edge of I. Okay, and apart from this, there is a frog who is initially standing at stone 1. Okay, and he will repeat the following action some number of times to reach nth stone, right? So frog can jump from ith stone to I plus 1 or I plus 2th stone. Okay, so there is a situation where there are n stones, and each stone is having some height from base level. This is height, this is height, this is height, this is height, and ith stone is having height h of I. And what I need to do is I need to calculate the minimum possible cost so that frog can reach from first stone to the nth stone, right? And if frog is making jump from ith stone to jth stone, the cost of this jump will be mod of h of I minus h of j. Okay, so let's see what kind of a problem is this, and the constraint for n is 10 to the power 5. Okay, let's proceed to the problem. So we are given a array h of n of size n. So let's consider if the frog is at the current position of frog is a particular stone. Let's say currently frog is at current stone. So he can make a transition to current plus one at stone or current plus two at stone, right? So at each particular stone, we have to make two decisions whether we have to make jump to next stone or next to next stone, right? So in this type of problems, in general, we can't use greedy approach. So let's try for a DP approach if we can make a DP approach. So let's say if I am using a DP state as DP of current, which is storing minimum cost to reach nth stone from this current stone, right? So if this is the DP state, let's try to make a transition. So if currently I am at this current stone, I can make transition to current plus 1 or current plus 2 at stone, right? And for for both of these particular jumps, I will be having two different costs, and I need to pick the minimum out of these. So let's say if I am making a jump of one step, in this case the cost will be dp of current plus 1, the next state, yeah, dp of current plus 1 plus the cost of this particular jump from current to current plus 1, which will be have giving me the cost which is equals to absolute yeah, mod of h of current minus mod of h of current plus 1. If I am doing jump of two step, let's say if I am going from current to current plus 2, so the cost for this kind of a transition will be dp of current plus 2 plus mod of h of current minus h of current plus 2, right? And I need to pick up the minimum of both these costs. So let's consider the base case for this kind of a dp state. So the dp state is saying the dp of current value is minimum cost to reach nth stone from the current stone, right? If the current stone is n itself, in that case I need to like dp of n is what? dp of n is the cost to reach nth stone if I am already standing at nth stone. Obviously this will be 0. So this is the base case for this particular problem. And the final sub problem will be dp of 1, which will be giving me the minimum cost to reach nth stone from first stone, right? This is the particular problem. Let's analyze the time complexity and space complexity for this problem. As we all know, in general, the DP solution, for DP solution, the time complexity formula is the number of states times 1 plus number of transition, right? And in this problem, the number of states, DP states will be n, as I am using one dimensional DP. and this current value can go from not 0, go from 1 to n. So the number of distinct dp states can be n, and the transition number of transitions for each dp state will be 2, because I can go from current state to current plus 1, or I can go from current state to current plus 2, right? So the number of transition will be 2, so the overall time complexity will be n times 1 plus 2, which will be linear also, linear only, and n is going up till 10 to the power 5, so linear solution will not give me TLE. So let's quickly go to the code. Yeah, so I have already coded this problem where I am taking n and k as input. Wait, this is code for second problem, right? So this I will discuss code for this first problem. So this was the frog 1 problem. Let's see what is given in frog 2 problem. Each and everything in this problem is similar to frog 1 problem. The main difference in this problem is this transition part, where frog can jump from ith stone to each of to any one of these stones. Let's say if frog is currently at ith stone, it can jump to I plus 1th stone, or I plus 2th stone, up till I plus k stone. So the basic difference in this and the first problem is in the transition. For each state, I can make k jumps. So the difference will in the algorithm will be this part. In this part, I will be exploring the particular possibilities, k plus like current plus 1 to current plus dp of current plus k up till plus this particular cost. So I will discuss this in coding part. In this particular problem, the number of transition will be k. So the overall time complexity will be n times k. 5, and k is up to 10 to the power 2. So it will go up to we go of 10 to the power 7. Again, it will not give me TLE, so I can code this. So here I have coded the general problem where I can jump up till k steps. So I have taken input as n and k, and a height array of size n plus 1, because I'm using one base indexing over here. So let's quickly see what I have done in DP part. So I have implemented this recursion function in which the base case is simple. If the current is stone is n, I will be returning 0. So this is the transition part where I have initialized the answer value with very big, let's say 1 in 9 value, because I need to minimize the DP cost. So I have considered this transition. I can make jump from ith stone to I plus, sorry, yeah, I can make jump from current stone to current plus ith stone. So I have taken, wait, yep, in this code I have considered all these possibilities. So answer is equals to minimum of answer comma recursion of current plus ith, the cost of going from, yeah, cost of going from current plus ith stone to nth stone, plus cost of this particular jump, which will be absolute value of h of current minus h of current plus I. And yeah, after that I have returned the dp state and call the final subproblem, which is recursion of 1. Let's quickly check for all the given test cases. Frog 2, right? uh, so output for this input will be, is taking some time. Yeah, 30, it's matching. Let's check for the second input. uh, Again 20, it is again matching. Let's check for third. So yeah, all the sample inputs are passing. So let's quickly submit this code. Let's see. whether this code is running or not. Yeah, it got accepted. So the slight difference in problem 1 and problem 2 is problem 2 is more generalized version of problem 1. You can replace k as 2, then this problem, the same code you can use for problem 1 also. So that's all for today's video. Thanks for watching. Bye bye.